Problem number 2. A company sells oatmeal in a cylindrical canister. Marketing research suggests that using a wider canister will increase sales. If the diameter of the canister is increased by 25% without altering the volume, by what percent must the height be decreased? Alright, well, let's draw a couple canisters here and kind of illustrate what we're talking about here. So we have the original canister, which is more tall and looks something like that. And the diameter here, across here, we'll call this D1. Okay, and the height, we'll call that H1. Okay. All right, now we're going to take the diameter increase it by 25%. So it's going to be shorter and fatter. All right, so let's draw another canister that looks something like this. I'm probably exaggerating. But it looks something more like this. And here the diameter is D2 and the height is H2. Okay? And we know the volume of the canisters is given by, so the volume is equal to, it's the area of the base times the height, right? So the base is a circle, right? We could draw, I don't usually think of base as being on the bottom, but it doesn't really matter here in this case. So here the base is pi r squared, right? So it's pi r squared h. Okay, this is the general formula for a the volume of a cylinder. Okay, so now let's use D1 and H1 here. And so V1, that's the volume of the first cylindrical canister, would be given by pi times, now we're given D, but let's work with, we need R, so that's D over 2, right? So D1 over 2, and that whole quantity squared, times H1. Okay, and V2 is going to be equal to pi times D2 over 2 squared times H2. Alright, and then we can just rewrite that as pi D1 squared H1 over 4. Okay, we get rid of the square on the bottom. So this is over 4. And this is equal to pi D2 squared H2 over 4. Alright. And we want those two volumes to be the same. Okay, so we're going to end up making these two equal to each other. Alright. I'll do that. And we know something about the diameter, the relationship between the diameter of these two. So we know that the diameter of the new container is 25% greater. So essentially, if we knew D1 and we add 25% to it, so that's one quarter of D1. Okay, so that ends up being 5/4, or 125% of D1. Okay, so we have this relationship here between D2 and D1. Alright, so we can substitute that in, and we're trying to find, by how much do we have to increase the height, or no, decrease the height, sorry. If you increase the diameter and you want the volume to be the same, then we have to decrease the height. Okay, so let's plug this into our formulas up here. So we have, and let's put everything in terms of D1. Okay, so wherever we see D2, we're going to substitute in this expression. Okay, so this is going to go in for D2, and then everything will be in terms of D1. Okay, so we have pi D1 squared H1 over 4 has to be equal to pi d2 squared. So that's 5/4 times d1, that whole quantity squared, times h2 over 4. Now these are equal to each other, so I could just divide both sides by pi over 4, and then we could get rid of that. Okay, so I'm just going to get rid of that. So if I divide both sides by pi and multiply both sides by 4, and then get rid of those constants. Okay, and so let me scroll down, and so we have d1 squared h1 is equal to, now let's square this in here, so this is 25/16 times d1 squared times h2. Okay, and again we have d1 squared now on both sides. Alright, so if I divide both sides by d1 squared, I can get rid of that as well. So now I have h1 is equal to 25/16 h2. Okay, so we have h1 in terms of h2. But we want to know what's the decrease in the height that's required to maintain the /volume. And so we really want to know what's h2 in terms of h1. And we can get that easy enough if we just multiply this times 16/25 and do the same thing to both sides. Okay, then I'm going to get this, the 16/25 times 25/16, that's just 1, right? So that goes away. So now I'm going to rewrite this. I'm going to write h2 is equal to 16/25 times h1. Okay. Alright, so 16/25, now we want a percentage, right? By what percent? And I'm seeing 25, and to get percentage I just wanted, how many out of 100, right? So let's multiply top and bottom. Let's multiply this thing by 4/4, okay? And then, what do we get? We get 64/100 h1. Alright, so I'm going to go over here and use this space. Okay, so now we have that h2 is equal to essentially 64% of h1, right? But we wanted to know, so you can see that 64, we had a certain original height, and we had to decrease it by a certain amount to get it down to 64% of its original height. So what is that percent decrease? Well, we had to decrease it by 36%. Okay, because it was originally 100% of h1, and now it's 64% of h1, and so it was decreased by 36%. Okay, does that make sense? Because essentially 1 minus 64/100 is equal to 36/100, right? So our answer is that the height had to be decreased by 36%.